Good morning, everyone. My name is Stephen Mellor, as introduced. Thank you very much. And today I'd like to talk about gaining real benefits from the proliferation of smart connected devices. A very long title. Next month I'll be on a panel which is a very related question. It has to do with data monetization. And I know the very first question will be, how am I going to make money out of all this data that I have from connected devices? My answer will be very simple. I have no idea. None whatsoever. And if I did, I wouldn't be here talking to you. I'd go and talk to some venture capitalists and see what I could do actually to make some money out of this. So unsurprisingly then, the real question is less exactly what are the possibilities, but rather how are we going to get there and find out. So my first slide here. There are lots and lots of predictions about how much money you're going to make, and some lovely, lovely graphs that show huge numbers of dollars. You can read off the numbers here quite easily, I think. I'm not going to do that for you. But, of course, we all know that these are simply stick your finger in the air guesses. Yes, of course, there's some data behind them. But I'm very suspicious indeed of top-down estimates like this, because you can make up any number you like, and if you want to have a bigger number, you just make the date later, and then you're further up that curve, and everything will be lovely. So I would prefer, actually, to think of this in terms of a bottom-up analysis. And this particular analysis was carried out by two economists at GE, Evans and D'Annunziata, in 2012. And what they did was they just said, in our lines of business, in GE, we work in energy, we work in transportation, etc., etc. How much could we gain if we just had a 1% improvement on our efficiency, on our costs? How much would we actually get from that? And these are the numbers that they came out with. Now, these are not backed up with anything that says how. This is just if I could get 1%. Improvement in efficiency, what would it mean? And here are the numbers they come up with. And again, they are really quite impressive. They're really quite large. Just think about one example, maintenance. One option to maintain a device, your car or a turbine or something that makes a particular, that manufactures things, a robot outside. One way to maintain it is to wait till it breaks. Another way to maintain it is to do it every year, 6 months, whatever, whether it needs it or not. The third option, of course, is to predict the performance of the device and then work out when it needs it. So you can see right away, just with that one single example, that savings can be had. Whether it's 1% or not, we don't know yet. So what do we need actually to make this work? The first thing that you need is some kind of business strategy and innovation framework. What we at the Industrial Internet Consortium are doing is trying to understand some of the things that we need to do as we move into an Internet of Things, smart IoT, connecting devices to the Internet world. And a couple of things stand out right away. First of all, you're going to be learning. And what that means is that you need to build things fast and see what works and see what doesn't. And this is an important thing for companies to understand, because large companies, Boeings, GEs, Airbuses, are used to making huge bets. I'm going to build an A380. It's going to cost this much, and for me to make any money out of it, I need to sell so many hundreds or thousands of units. That's not how it is in IoT. Right? You have to be thinking, instead of, let me try this and see what works, see what I can get. So there's a lot of innovation, a lot of learning to be done, a lot of work that you need to do to change the attitude. Another fundamental issue that you need to change in terms of attitude is keeping the IT people and the OT people talking, the operational technology people talking to each other. They have completely different cultures, and you need to bring them together in some manner. At the bottom here, you can see a link. I'll make these slides available, of course, if you either give me a card or I don't know what the conference is doing about it. But should anything go wrong, it's really easy. It's iiconsortium.org/visf.htm in uppercase letters. So that's easy to find. And what that document covers, in about 50 pages, it's a fairly easy read, is how you go about thinking about what your project is going to be, ideation, all the way through getting started and implementation. It does not, of course, describe all the technology that you need, but rather it says the kinds of things that you need within your organization to back that up. And so one thing that is very important to understand this learning idea is a center of excellence of some sort. You need to identify the IoT platforms that you're using. You need to understand what's changing and how you're going to manage that change. You're going to need to find internal consultants. Of course, you can always hire outside or external consultants, but if you're going to build the expertise in-house, you have to have a place to keep it. So a center of excellence that's focused on this kind of project will make a huge difference. You need also to benchmark your projects, figure out what's working and what is not. So by doing these kinds of things at the business strategy level, you can help get closer to gaining the values that we hope to gain from connecting devices to the internet. You also need a set of technical references. And this is important because we don't want to reinvent the wheel. And so again, the Consortium has been working on this for some time. We published the Industrial Internet Reference Architecture. You'll be amazed to know you can find it at the iiconsortium.org site /IIRA, all uppercase, .htm. And we also published a security framework at the end of last year, September 2016. We're already in 2017 and I'm still writing 2013 on my checks. In addition, there are several other areas that we need to understand. One of them is connectivity. We published a connectivity framework at the end of last month. Amazingly enough, IICF. There you go, easy to find. And we're also working in a variety of different areas, such as data management, data distribution, how you're going to access, store, and provide permissions for the necessary elements. So all of these things, I think, are needed as a way to get you started, and these are all freely available. We don't even ask you for your email address. So let's talk a little bit about the security framework, because I think that this is a key issue that could easily derail the potential benefits of the industrial internet. Think about GM foods, for example. Once people got the idea they were dangerous, it's almost impossible to root the idea out. If we had a big disaster, an IoT disaster, a chemical plant, for example, gets hacked and throws a whole bunch of unpleasant chemicals into your local river, that could set us back a long, long time. What we actually need is a right-sized disaster, something that's big enough to get people's attention in the boardroom, but small enough not actually to hurt anybody. But good luck with that. We'll just have to see what happens as time goes by. This diagram attempts to represent how it is that the real world, the reference architecture, and the security framework fit together. They're not intended to be layered as such, but rather they're intended to kind of show the relationships between them. In the physical world, on the bottom layer, you see at one end the operational technology that's controlling physical devices, and at the other end, the IT end, the data, the cloud, and so on and so forth. That is connected together using connectivity or communication technologies, and that then can be thought of in two different ways, the edge and the cloud, depending on how you think about that, and of course where you put the computing power. At the middle layer, you see the underlying framework that is proposed by the Industrial Internet Reference Architecture. Now, these boxes are very small. The words inside them are even harder to read. But basically, at the one end, you have sensing and actuation, which obviously is closely related to the operational technology that's happening in the physical world. And then at the other end, you have the business, which is where you derive value from the data. And in the middle are a series of other boxes, applications, business, connectivity, communications, etc. And each one of those boxes can be broken down. And that's what we did in the Industrial Internet Reference Architecture document. If you read that, you can use it for two purposes. One, as a guide to help you understand what you need and what you do not. But also, we're going to use it to help drive standards development activities. The IOC is not a standards development organization. What we hope to do is to identify requirements that come about from trying to build industrial strength systems. And then at the top, you see the security framework. And each one of those boxes there represents a chapter in 170 pages. This is not a light read, but of course it is very important. You need to be able to understand for each one of these components, first of all, protecting the endpoints, protecting communication, data management and control, security model and policy, and all around that, data protection. So this is a key diagram that outlines the structure of what we need to do to secure IoT systems. Now, earlier I mentioned the issues related to IT people and OT people talking, and the fact that they have very different cultures. Let me give you just one example. If I say security to an IT guy, that person will think what we're talking about here is viruses, firewalls, worms, those kinds of things. If I say security to the lady who's running the plant, the chemical plant, the manufacturing plant, she will think armed guards, barbed wire. Same word, completely different meaning. And this is very important because those 5 boxes that I'd like to see again, please. Security, privacy, resilience, reliability, availability, they all go together and they have different strengths, different emphasis, depending on which point of view you take. IT people don't think very much about safety. Operational technology people think about that first. So getting those cultures and those languages together is very important. And when they are all put together, they have a concept called trustworthiness. And this, again, needs to be taken to the boardroom if you're ever going to get the benefits from connecting your smart devices to the internet. So I've mentioned the Industrial Internet Consortium a couple of times. We are a global organization. We are not a standards development organization, but we were founded by 5 large companies in March 2014, so that's 3 years ago now. IBM, GE, Intel, AT&T, and I always forget one, Cisco. Got it, finally, just in time. We are now around 270 members from 33 countries. We meet globally 4 times a year. Last time was in Washington, next is Berlin. After that is Singapore, which will be nice and toasty. Not cold and grey like it is in Manchester, but never mind. We have a long mission statement, which is to be expected if you are founded by 5 global companies. But the 3 words that really matter are the 3 at the end: transformational business outcomes. We are trying fundamentally to change the economy. That's our goal. And that is why we are publishing these various elements, why it is that we are working together to understand the requirements and bring them then to standards development organizations so that we can connect across sectors. Now that little last 3 words there, connect across sectors, is very important because the World Economic Forum published a document some time ago showing 4 phases. In the first phase, what we're talking about is simply the operational efficiency of your particular plant. Now, earlier I said, what happens if we could gain just a 1% improvement? And I gave you some examples of where we might do that. GE is currently finding around 4% improvement in just their lines of business, 4 years on from the publication of that paper. So that says that there's a lot going on. Now, as we proceed, we're going to be changing the economy in ways that we're already seeing. Uber, Zip cars or Go cars, depending on which particular company you use. A whole series of schemes whereby people don't own assets so much as they try to pay per use. Right? That's a big change, and that will again cause additional benefits as you look across fleets of your factories or fleets of aircraft engines. Rather than simply thinking in terms of optimization of a single device, think about optimization of a fleet of devices. Now, later, and of course predictions are always difficult, especially about the future, but the World Economic Forum believes that we're talking about 7 to 10 years out, we'll move into the next phase. And that next phase is starting to think now about paying by outcome, right? It's not that I want to pay for the use of my aircraft engine, it's that I want to pay for getting me from A to B, however it is that you do it. Right? So they're predicting these kinds of changes in the economy, ending with the autonomous pull economy, where I might think I want something, and lo, that goes through the entire supply chain, all the way to create the particular thing I want, all through the logistics, and delivered to my door the following day. Now, the thing that's important about that is connecting across sectors, right? It's all very well improving the operational efficiency of my factory or factories. It's all very well selling them slightly differently. But what happens when we connect different sectors together? Healthcare and transportation, for example, or manufacturing and logistics. As we begin to do that, these benefits will multiply. It's, of course, the famous network effect, right? And that network effect grows, we get more benefits as we connect more and more things to the internet. My phone, for some reason, is not presently connected to the internet. I have no idea why. It's annoying me no end. But if I were able to do that, I can summon up a car and get out of here. Right? That's connecting completely different things together. When people first thought about telephones and communication, they weren't thinking about Uber. They had no idea. And that's where we are today, right? The internet you could think of as being invented in the mid to late 80s, so we're 30 to 40 years on. The industrial internet, connecting smart devices to your machines, well, they are just at the beginning of that, maybe 5 years old. So what we'll be doing in 20, 25, 30 years on from now, we're going to find very hard to predict. Certainly I can't, as I said right at the beginning. But as you can see, the potential is there, and it's already being realized. So I just want to go back one slide just to show you, oops, I forgot I had that animated, just to show you how these elements fit together. I showed you the four boxes representing the technical references and the business strategy. The green box on the right represents test beds. The IIC currently has 22 test beds that are approved and public, and they're actually building things and getting real benefits today, and we are learning from them. Still early days, but we're getting some results back now. And as I said when I introduced the the strategy framework, one of the things we need to do is experiment, and that's how we're doing that. So putting all of those things together, thank you very much. I understand questions will be afterwards, so I won't show you that slide. Oh, I said I wouldn't. So thank you very much. Onwards.